3 by 2. Now let me use the same formula. For object distance, it is moved by 0.04 meter. 0.04 meter is decrease, means 0.2 meter is the object distance. Therefore 0.2 by focal length equal to 1 by magnification. This is wanted plus 1. Now here is equation 1. Equation 2, solve for m prime. M prime turns out to be 4. I don't have space to solve. It takes about 10-15 seconds. So solve for m prime. That turns out to be 4. This is taking more time. We can save time in other problems. So it's really fine. That is why don't waste time when you know the answer. Speed of light in medium m1 and m2 are 1.5 and 2 lakh km per second respectively. Therefore refractive index equal to speed by 1.5. Of course it is 10 power 8, 10 power 8, 10 power 8, 10 power 8. So it is 4 by 3. This is refractive index of the medium. A ray travels from medium 1 to medium 2 with an angle of incidence theta. Medium 1 to medium 2. This is the angle of incidence theta. The ray suffers total internal reflection. The ray undergoes total internal reflection, means this theta should be greater than c. But sin c equal to 1 by refractive index. Therefore c equal to sin inverse of 1 by refractive index is 3 by 4. Therefore theta should be greater than sin inverse of 3 by 4 is the answer. Which of the following phenomena support the wave theory of light? Wave theory of light means Huygens wave theory. Huygens wave theory. Unless it is mentioned electromagnetic, it is Huygens wave theory. If it is electromagnetic, then it is Maxwell's. Okay. Scattering of light is a particle nature. So this is not the answer. Interference can be explained using wave nature. Diffraction can be explained using wave nature. Velocity of light in denser medium is less than velocity of light in rarer medium. True. So BCD 3. White light reflected from the soap film has a maxima. So this is related to interference at thin film. This is not there in your syllabus. 21st. A cylindrical tube of length, radius, sugar solution, concentration produces rotation of plane of vibration, polarization. This comes under optical activity. This is also not there in your syllabus. Radii of curvature of a converging lens are in the ratio 1:2. Therefore R1 is to R2 equal to 1:2. So R1 by R2 equal to 1 by 2 implies R1 equal to 2R1 equal to R2. Okay, so we have a relation. Focal length is given, refractive index is also given. 1 by focal length equal to n minus 1, refractive index minus 1, 1 by R1 minus 1 by R2. 2R1, refractive index 1.5, minus 1 is 0.5. Focal length is 6 centimeter. 6 into 1 by R1 plus 1 by 2R1. Take R1 common factor, take it to the other side. R1 equal to 6 into 0.5 is 3. 1 plus 1 by 2. 1 plus 1 by 2. Or simply solve for R1. Okay, doesn't matter. So R1 equal to 3 into 3 by 2. 3 by 2. 9 by 2 is 4.5. 4.5 centimeter. Since focal length is in centimeter, this is 4.5 centimeter. So in these options, 4.5 is with fourth option. Of course, we can show that it is 9 centimeter. The other surface is 9 centimeter. 2 times this. 2 times. 23rd, a small oil drop of mass 10 power minus 6 kg is hanging between two plates separated by having potential difference, the charge on the drop. This is the oil drop. This is weight of the oil drop, mg. Electrostatic force. If it is equal and opposite to mg, then the oil drop is suspended. Therefore, F. So F equal to m into g. Force is charge into electric field equal to m into g. Electric field is potential difference by distance between the plates into q, m into g. What we want is q. Charge on the drop. Charge equal to mass. Mass is 10 power minus 6 kg. G is 10. D, distance between the plates, is 10 power minus 3 divided by voltage, potential difference 500 volt. 500 volt by 500. 10 by 5 is 2, minus 6 minus 3 minus 2, 10 power minus 11. So second option. Question is wrong. Our question is correct. Options are not correct. Therefore, grace. Two metal spheres of radii 0.01 meter, 0.02 meter are given charges. So this is one metal sphere of radius 0.01. This is second sphere 0.02. Charges are 15 millicoulomb, 45 millicoulomb. Therefore, total charge is 60 millicoulomb. Okay. When they are connected by a wire, then transfer of charge takes place till they acquire same potential. Therefore, potential of first sphere equal to potential of second sphere. But potential equal to constant into charge by radius. Charge by radius. Here charge by radius, charge is here constant, charge by radius of first is 0.01, charge into radius of second 0.02. Therefore 0.01 by 0.02 equal to 0.01 by 0.02. This constant get cancels with this. Charge of this is charge on first, charge on second, q1 by q2. Q1 by q2. So this is half of this. Therefore, there should be half of this. Sum of these two charges is 60. The 60 millicoulomb is shared in the ratio 1:2. 1:2. Therefore, possibilities are 20 millicoulomb, or possibility is 20 coulomb and 40 millicoulomb. In smaller radius, small charge is observed. Therefore, final charge on the first sphere is smaller radius, therefore smaller charge 20 millicoulomb. Two concentric spheres of radii r plus r having positive charges q and q. There are two concentric spheres with equal surface charge densities. Surface charge density sigma, here also sigma. Radius of inner and outer. Radius of inner r, radius of outer capital R. What is the electric potential at their common center? Electric potential at the common center. Potential is constant. Potential inside the sphere is constant q by r, where r is radius. Okay. Because of outer sphere, potential is V1. Because of inner sphere, potential is V2. But surface charge density is equal to charge by area. Charge by area. This constant is 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught. Charge is surface density sigma into A. Sigma into A. Area of the sphere is 4 pi r square divided by r. 2 pi get cancels, r get cancels. As a result, we get potential equal to sigma r by epsilon naught. Sigma r by epsilon naught. So this is the expression, sigma r by epsilon naught. Okay. Now, because of outer sphere, V1 is sigma r by epsilon naught. Because of inner sphere, sigma r by epsilon naught. This is the total potential. Sigma by epsilon naught is common factor, therefore r plus r. R plus r. This is minus 1 by r by r, therefore this is the correct option. When an additional charge of 2q is given to a capacitor, energy stored in it is increased by 21%. Original charge on the capacitor. Energy equal to half CV square, also equal to half q square by q square by c, and q equal to cv. So these are the equations that we know. Additional charge of 2c is given. Let us consider E equal to half q square by c. Additional charge is given means q plus 2c square divided by c into half equal to, increases the energy by 21%. It is 1.21 times E. Now divide one by the other and simplify. C capacitance get cancels, 2 get cancels, E get cancels. So we are left with 1 by 1.21 equal to q square by q plus 2c square. By taking square root 1.1 equal to q by q plus 2c. Solve for c, it turns out to be 40c. When a potential difference of 10 power 3 volt is applied, potential difference charge is observed, potential difference charge. Therefore, for a capacitor we can write q equal to cv, potential difference charge. So we can find out equivalent capacitance, q by v. Q charge is 0.75 millicoulomb divided by voltage 10 power 3. 10 power 3 goes to numerator, 0.75 into 10 power minus 6. This is the equivalent capacitance of this. This diagram can be written as these two capacitors. From there it branches, one with 2 and 2 in series, 2 and 2 in series, the other one has C. So these two are connected to 10 power 3 volt. Okay, this is 2 micro, 2 micro, 2 micro, 2 micro, this is C. If these two are in series, equivalent is 1. These two are in series, equivalent is 1. 1 plus C. So 1 plus C is in series with 1 microfarad. 1 microfarad. So this can be written as 1 microfarad in series with 1 plus C. 1 plus C microfarad. But C equivalent equal to, since these two are in series, C1 C2 by C1 plus C2. In this case 1 microfarad into 1 plus C microfarad divided by 1 microfarad plus 1 plus C microfarad. Simplify this. The equivalent, the C value is found to be, this is the unknown, C equivalent is already found out. Therefore C turns out to be 2 microfarad. This is taking some time. We can save time in other problems, so spend some time on this. In the diagram, area of each plate is given, distance between the plates is given, charge is given, then potential of Q becomes potential of Q. If this is minus charge, this is plus, because this behaves like a parallel plate capacitor. If this is plus, this should be plus. If this is plus, this is minus. Minus plus plus minus. Minus plus plus minus. Two capacitors are in series means plus minus plus minus, alternate charges. If two capacitors are parallel, plus minus minus plus, plus minus minus plus, minus plus plus minus, then these two capacitors are in parallel. If these two capacitors are in parallel, therefore C equivalent equal to C1 plus C2. But capacitance of parallel plate capacitor is epsilon naught A by D. Okay, let us solve this first. Epsilon naught is 8.85 10 power minus 12 into area of cross section, area of each plate 2 meter square by D. Distance between the plates is 2 10 power minus 3. Okay, C1 plus C2, C equivalent. We also know Q equal to CV. Therefore V equal to Q by C. Therefore charge is given 8.85 10 power minus 8 divided by C is C1 plus C2. C1 plus C2. C1 plus C2 is epsilon naught A by D plus epsilon naught A by distance between these two is 2D. Therefore when we simplify, 8.85 10 power minus 8 by epsilon naught A by D common factor, 8.85 10 power minus 12 is epsilon naught, A is 2 by D is distance between the plates is 2 10 power minus 2 into 1 plus 1 by 2, 3 by 2. So we have to solve this. This 8.85 get cancels with this 8.85, 2 get cancels, 2 by 3, 10 power minus 2, 10 power minus 10 minus 12, this is 10 power minus 10, this is 10 power minus 8, 10 power minus 8, 10 power 2. So this is 10 power minus 1, 6.67 volt. 6.67 volt. 3 conductors draw currents. This is grace. From 31st question to question number 31 to question number 16, refer the next video. Thank you.